Hello, everyone, and good day. The Coordinating Center for the National Drug Early Warning System, NDEWS, and the National Institute on Drug Abuse, NIDA, are very excited to welcome you to our first NDEWS Presents monthly webinar. My name is Erin Artigiani, and Kathy Garcia and I will be your facilitators this afternoon for this webinar. We are part of the NDEWS coordinating team, and NDEWS is supported by funding from NIDA. And for those of you who are interested in learning more about NDEWS, please go visit our website at www.ndews.org, and you'll find all of our recent reports and information about drugs of abuse and information about future webinars and other things as well on that site. And our NDEWS Presents webinars are a new feature that we developed as a way of disseminating information and working with leading substance abuse experts to explore emerging drugs and timely drug-related topics. We're planning to do one a month, and we're delighted this month to have a really great presenter with us to kick things off, and her name is Jill Head. She is the Supervisory Chemist of the U.S. Drug Enforcement Administration, or DEA's Special Testing and Research Laboratory. She is also a member of our NDEWS Scientific Advisory Group, and she will be presenting on the history and evolution of synthetic drugs and on newly emerging psychoactive substances, with a special focus on the newer fentanyls that her lab has been encountering. We expect the webinar to last approximately 90 minutes, and we encourage all of you to submit questions both during and after the presentation. However, don't use the raise hand feature. We would like you instead to submit your questions through the Q&A feature that you should be able to see at the top of your screen. And Jill and Kathy and I will do our best to keep up with your questions and make sure they all get answered. Jill has suggested that she would like to speak first and then get to your questions afterwards. So her presentation is expected to last about an hour, and then that will give us some time for Q&A afterwards. And in addition, this webinar will be recorded and it will be posted on our website. And so if there turn out to be questions we don't get to, or if you have additional questions afterwards, you're welcome to email them to us at ndews@umd.edu, and we'll be happy to get back to you. And we can also post a Q&A on the website along with the recording. So I hope you enjoy our presentation this afternoon, and I will turn things over now to Jill Head.
Right. Thank you, Erin. Thank you, Kathy. And thank you to everyone here at NDEWS and CESAR that invited me to speak with you this afternoon. I'm honored to be here and to be given an opportunity to have this discussion with you this afternoon. Like Erin said, my name is Jill Head. I'm a supervisory chemist with the Drug Enforcement Administration Special Testing and Research Laboratory. And I'm the supervisor of groups of forensic scientists. And we are dedicated to the analysis and research of identifying and answering questions about new and emerging synthetic drugs of abuse. So that's going to be the focus of my presentation this afternoon. Okay. The focus of this presentation is going to be on emerging synthetic drug threats in the United States. The United States is currently undergoing many drug threats, particularly with the heroin epidemic and pharmaceutical and prescription drug abuse. But that's not going to be so much the focus of this presentation, although I do recognize that that is a major problem. But this presentation is going to focus on synthetic drug threats. Before I get started into the real content of this presentation, I just want to give a very general overview of what synthetic drugs are. I understand that there may be many people that are watching this afternoon that may be very knowledgeable in this area, but I'd like to give just a very general overview so that we all understand what I'm speaking about today. So synthetic drugs are man-made substances that are manufactured in a laboratory. So those are going to be substances such as methamphetamine or ecstasy, which is MDMA, or PCP. These are not substances like cocaine that are derived from plants or heroin. So this presentation is going to primarily focus on 4 classes of synthetic drugs called synthetic cannabinoids, synthetic cathinones, phenethylamine hallucinogens, and synthetic opioids. So I'll start by discussing synthetic cannabinoids. One of the things that I'm going to refer to throughout this presentation has to do with how we're referring to these drugs and what they are and some of the complications that we encounter with what we're calling them, how we're naming them. So I'm going to begin from the very beginning. There's been many media stories, journal articles and publications and TV and news recordings that are talking about spice and K2. So what are exactly spice and K2? Spice and K2 were actually the earliest brand names of an herbal smoking blend that was found to contain a synthetic cannabinoid. So I have pictures of the packaging of spice and K2. They're also commonly referred to as herbal smoking blends or synthetic smoking blends, herbal incense. But one of the nomenclatures that I try to avoid is using synthetic marijuana. Synthetic cannabinoids are not synthetic marijuana. Marijuana is a plant that is abused, whereas synthetic cannabinoids is actually a powdered drug. So in addition to spice and K2, there are literally hundreds and hundreds of different brand names of synthetic cannabinoids. So here's some pictures of some very commonly encountered packaging or brands of synthetic cannabinoids. We also not only see them in these foil packets, but also in Ziploc bags, and they may not have brand names at all. One of the things that I wanted to point out about the packaging is that these drugs are often mislabeled to hide or camouflage their intended purpose. So they may have statements on them like not for human consumption or laboratory tested. They may say keep out of reach of children, or that they're an incense, such as this one here with the picture of caution, that it's incense and to burn in a well-ventilated area. Some actually say that they're DEA compliant or legal in all 50 states. Rarely, or probably never, will it have any statements about what these packages actually do contain. So what I'd like to do now is talk about what is actually in these foil packets. So what's in here is a combination of ingredients that makes up the smoking blend. So it's a synthetic cannabinoid, which is a drug, which is a drug powder that is then dissolved in a solvent. So what that means is that the drug powder is dissolved, much like sugar is dissolved into iced tea, and it disappears in the solution. The drug powder is added to a solvent like acetone or grain alcohol, and then sprayed or mixed onto a plant material. And then it's allowed to dry, then added to foil packets, maybe some flavoring added, maybe strawberry or blueberry, other fruity type flavors, and then sealed and packaged and sold. Oftentimes, when these synthetic cannabinoids or smoking blends are processed, they're done on a very large scale. The synthetic cannabinoid is often, it's imported into the United States. There's no known domestic synthesis of synthetic cannabinoids here in the United States. It's imported, typically mislabeled to prevent identification by customs, in packets that are very similar to the ones seen here on this slide. On the right hand, in the top right hand corner, are large bags of the plant material that's used, that's dosed and then put in the foil packets. It's commonly in there would be plants such as damiana leaf or marshmallow leaf or mullein. And in the bottom of the screen is an example of a processing facility here in the United States where these drugs are being mixed and packaged. So the part of the process where the drug is added to the plant material we call dosing. And typically this can be done in cement mixers or in a bathtub or in a giant plastic tub and mixed. And what happens in this process is it's very possible that the drug is not added consistently throughout that container. And what happens is the drug could be inconsistently dosed throughout that plant, and then when it's packaged, it's also inconsistently dosed. And the danger with that is there could be hot spots. And what I mean by hot spots is areas of the packaging or of the plant material, and there's a very large dose of drug. And for an individual that is smoking that material, that could be very dangerous because it could be a very high dose of a synthetic cannabinoid. So I'd like to talk a little bit about the history of synthetic cannabinoids. As I started preparing for this presentation, I went back and I looked at some of the history that we've put together previously. And back in several years ago, when we first started to really look at these materials, it was very new. It was a new and emerging threat in the United States. But that was 10 years ago. The first smoking blend was seen in the United States, or was seen in Europe in 2006. Here in the United States, it emerged in 2009. And within 2 years, the Drug Enforcement Administration added 5 synthetic cannabinoids to the temporary scheduling list. In 2012, the Synthetic Drug Abuse and Prevention Act took effect. And then since then, another 10 synthetic cannabinoids have since been temporarily scheduled. So one of the ways that I wanted to discuss sort of the scope of this problem is in terms of how many synthetic cannabinoids have actually emerged here in the United States. So in 2009, 2010, we were seeing synthetic cannabinoids here in seized drug evidence within the Drug Enforcement Administration of substances that go by the name of JWH-018, JWH-073, JWH-250, and CP47-497. At that time, in 2009, 2010, the majority of the synthetic cannabinoid or smoking blends that were here in the United States contained those materials. So in 2011, when the first synthetic cannabinoids were first scheduled, we, within weeks, saw these materials not being seized and added to synthetic cannabinoid smoking blends, and we started to see them replaced with new materials. And so that's what we see in 2011. In 2012, again, there was the control of an additional several synthetic cannabinoids, and we saw the emergence of more synthetic cannabinoids. What's interesting to note, between 2011 and 2012, we were seeing synthetic cannabinoids that had never been previously identified. The original synthetic cannabinoids that go by the name JWH were synthesized for legitimate medicinal research. In 2011, we started to see synthetic cannabinoids that had never before been published in scientific literature and had never been studied for medicinal purposes, such as RCS4 and RCS8. By 2013, the majority of the synthetic cannabinoids that we were identifying had no medicinal research at all. And you can see in a couple of slides, I'm going to talk a little bit more about the naming of these materials and what it means. Thank you. Okay, so so what are all of these names, and what are they? So like I mentioned, the original synthetic cannabinoids that we saw in smoking blends went by the names of JWH, which stands for John W. Huffman, which is the name of the scientist who was conducting the research. AM 2201 is another one, which the AM stands for Alexandros Makarianis, who was another researcher that was studying the effects of these materials. So in 2011, when we started seeing RCS4 and RCS8, there had never been any published scientific literature about these. And these were actually named after the website that was selling them, which stood for Research Chemical Supply. In addition to that, we started to see pop culture references. So To Anyone is the name of a Korean girl band. AKB48 is the Japanese girl band. XLR-11 is the first liquid-fueled rocket, and BB-22 is the USS Minnesota, and STS-135 is the final space shuttle mission. So these are names that really have no association with the drug themselves, but it's a reference to pop culture. Some of the most recent synthetic cannabinoids have names that seem very strange. They're actually based very loosely on something called an IUPAC name, which is a name that scientists and chemists use to name compounds, molecular compounds. And so, for example, AB Fubinaca, which is the second one under that category, the IUPAC name is listed there at the bottom. And so certain parts of that name are combined in order to be able to name that compound. Just to sort of illustrate this point, and I am a scientist, I'm a chemist, and so of course I have to show a little bit of chemistry here. But I'd like to point out 3 molecules in particular. On the top right-hand side is something called PB22, and there the part of that in green I have circled, and then at the bottom where it's AB Fubinaca, I have another part in purple that's circled. That FUB stands for a fluorobenzyl ring. And so in order to make a new synthetic cannabinoid, parts of previously encountered synthetic cannabinoids were actually combined to form something totally new. And the evolution of synthetic cannabinoids is something that's very important for us to discuss. Originally, when we first saw the new materials, there was very much a market for synthetic cannabinoids to stay legal, to avoid drug testing, for court purposes, for probation purposes, for job employment purposes. That's changed a little bit. I'm going to talk about that in a minute, but these cannabinoids are constantly changing. And this is an example of taking bits and pieces of synthetic cannabinoids that had been controlled to form something totally new. This is an example of a synthetic cannabinoid that goes by the brand name of Scooby Snacks. And although this data is from 2013 and 2014, I thought it showed a really interesting point. On the same date in June 18th, 2013, there were 2 seizures of this package, 2 separate seizures. And one of the packages contained something called 5-fluoro-UR144, and the other package contained one called 5-fluoro-PB22. So it's the same package, the same date, but yet 2 completely different drugs were, or 2 different drugs were identified. 2 days later, the same brand, Scooby Snacks, was seized, and within that package, there were 3 synthetic cannabinoids contained within the same packet. So it's not just one drug per package. It could be multiple drugs per package. And then in February 2014, we saw the same 2 drugs from the original 2 packets, but they were combined. And then just 1 month later, we started to see the emergence of AB fubinaca in that material. In addition to packages that are labeled and branded, we've also seen synthetic cannabinoids in e-cigarettes. E-cigarettes or vaping has become quite commonplace, but we have been identifying synthetic cannabinoids in the liquids of e-cigarettes. For example, on the left-hand side, in one called Mad Hatter, AB pinaca and nicotine were identified. In the middle one, AB fubinaca was identified, and then in this refillable liquid on the right, AB fubinaca was also identified. Here I have some data from 2015 of compiled from analytical results from the DEA laboratory system. Our laboratory system has a centralized database where all of the information is stored. And throughout the course of this presentation, I'm going to be routinely referencing that data. So one of the things here that I'd just like to mention is that I'm trying to provide the most current information that I can. And so there are some limitations with the data that I'm going to provide, but I'm going to explain that as I go. This data comes from that database for drug exhibits that were seized and analyzed between January and June of 2015. I've also included here the location of that seizure. The thing here that I wanted to point out is something that I mentioned a few minutes ago, is about the combination of substances that are present in these smoking blends. So for example, in January 2015, in the south central part of the United States, we've seen AB fubinaca combined with 5-fluoro-AB pinaca. We also see them adulterated. Because the synthetic cannabinoids are being imported into the United States as bulk powder, they're being cut here, meaning that they're being diluted with another substance before they're added to the plant material. The same way that cocaine and heroin and methamphetamine are cut before they're sold to increase the profit. This data here does come from the DEA laboratory system analytical results. And this data encompasses exhibits that were seized and analyzed from January 2015 through December 2015. And this is a sort of a snapshot of what that information looks like now. As new evidence is analyzed that's waiting in the laboratory system to be analyzed, and new reference materials are available to make an identification, this is subject to change. But this data was compiled within the last week or so. And here, what you can see here is that there were 1,212 synthetic cannabinoid identifications made in 2015 within the DEA laboratory system. And the number one most identified synthetic cannabinoid was 5-fluoro-UR144, which also goes by the name of XLR11. What's important to discuss here is that XLR11, or 5-fluoro-UR144, is a Schedule I controlled substance. So this attempt to stay legal and this being viewed as a legal high, I think is a little bit misleading now, because this synthetic cannabinoid is a Schedule I controlled substance. Same with AB fubinaca, AB pinaca. These are Schedule I controlled substances, but they are the top most identified and seized synthetic cannabinoids in the United States by DEA. These are synthetic cannabinoids where there were less than 10 identifications made by forensic chemists in DEA. And although the number of identifications is not high, what I think is interesting about this information is just the number of synthetic cannabinoids that are available right now all at the same time. And just to point out, an identification is an instance where a forensic chemist has a reference material available for comparison and identifies that substance in evidence. There's no differentiation between sizes of seizures. So it could be one packet, could be an identification. It could also be 15 kilograms could also be an identification. So just to clarify, that identification doesn't necessarily mean there were only 74 samples. So switching gears a little bit, I'm going to move on to synthetic cathinones. And just like the synthetic cannabinoids, when they first emerged, they were misbranded and mislabeled, and probably the most notorious name is bath salts. So back in 2009, again, bath salts there was a lot of media attention. There were stories about really horrific experiences that people were having under the influence of bath salts. Zombies and face eating really caught a lot of negative media attention. But a bath salt is a designer drug typically containing synthetic cathinones or phenethylamines. Like the smoking blends, they were marketed as legal highs. They came in packages like foil packets or small jars, and were labeled with statements such as not for human consumption, or does not contain methadone, or does not contain any harmful or illegal substances. They were also called plant food or glass cleaner, badger repellent, bug repellent, went by lots of different names, and also by research chemicals. The research chemical name, the idea is not new. It's people using chemicals and experimenting with various chemicals and drugs, and that name has stuck around and is commonly still used. But largely, the bath salt phenomenon has diminished. We don't typically receive in the laboratory anymore, we don't typically receive bath salts or branded synthetic cathinones. Typically now, we see them in the same sorts of containers as other illicit substances, such as cocaine or heroin or methamphetamine. So the commercial packaging is gone, but the synthetic cathinones are still widely abused. Similar to the synthetic cannabinoids, synthetic cathinones are imported into the United States, and the packages are often mislabeled to get through customs. So here are several examples of synthetic cathinone packaging. The one on the right-hand side, on the top right corner, says titanium dioxide, and even lists the chemical formula for industrial use only, made in China. But in fact, it was for methylcathinone. The one on the bottom left-hand corner, I believe, was for fluoromethcathinone. So these were misbranded or mislabeled in order to get through customs. There's currently no known domestic synthesis of synthetic cathinones here in the United States. When they enter the United States, they're typically very pure, and then they are cut here and adulterated, or a diluent is added to increase the bulk, to increase the profit. So again, a little bit of history about synthetic cathinones. And in reality, the history is fairly long at this point. There's a lot that we know about these materials now. Many have been scheduled. So in 2011, DEA temporarily scheduled 3 cathinones. There were various synthetic cathinones that were added to the Synthetic Drug Abuse and Prevention Act of 2012. In 2013, methadone was permanently scheduled, and then after that, an additional 10 cathinones were temporarily scheduled by DEA. So this is a list of some of the common synthetic cathinones. Some of them are cathinones and some are other classes of synthetic drugs that were identified in some of these branded materials. So it's not all cathinones, but they fall in this category. Each of these are powders. They all look fairly similar, white powders, and common adulterants and diluents such as sugars and starches and caffeine, the same sorts of diluents that are added to drugs like cocaine and heroin are used to cut synthetic cathinones as well. I'd like to tell the story of Molly. Molly is another material that has fallen in this name war and has a misinformation because the name may be confusing. So back in the early 1980s to early 2000s, ecstasy tablets typically contained MDMA, or 3,4-methylene dioxymethamphetamine. In 2006, ecstasy tablets started to see a decline of MDMA and an increase of 2 drugs, one called BZP and one called TFMPP. Shortly after these ecstasy tablets had this combination, it wasn't widely popular. And so that started to decrease, and there was a rise in crystal or powdered form of MDMA. So instead of it being MDMA in ecstasy tablets, it was MDMA as a pure powder, and that was called Molly. However, many of the current Molly investigations have been found to not be MDMA, but to actually be methadone or other substituted synthetic cathinones. The reason for this is that MDMA is fairly expensive, whereas the cathinones are cheaper and they're very easy to obtain. And so many of the Molly investigations now are not MDMA, but are actually bath salts. Molly, bath salts, flocka, gravel. These are all slang terms or street terms for this synthetic cathinone class of drugs. Flocka is another one that's gotten a lot of media attention, particularly with the widespread abuse and overdoses in particular parts of the country, such as Florida. Flocka, again, is another street name for this material, which is typically alpha PVP. It can be white, brown, purple, pink, or blue crystals, which is the photo seen on the left, whereas gravel, which is the name for alpha PVP in other parts of the United States, such as Kentucky or Tennessee, often is a off-white, brown, or beige powder and has kind of a rock-like form. So the form may be different, the appearance is different, but both flocka and gravel typically are identified through forensic analysis to be alpha PVP. It can be other materials like methadone or ethylone, but the majority is, at least in seizures analyzed by the Drug Enforcement Administration, are alpha PVP. So in 2015, the majority, almost 60% of the synthetic cathinones or stimulants identified were ethylone. The vast majority were ethylone. Second to that was alpha PVP. And then after that, there are many other types of materials identified, but clearly ethylone and alpha PVP were the most widespread and seized in 2015. Again, this data is compiled from DEA lab system results and encompasses drug exhibits seized and analyzed between January and December of 2015. So much like the synthetic cannabinoids, the cathinones are adulterated also. And what that means is an additional substance is added to it. But what's interesting about the cathinones is the range with which other substances are identified in the same powder as the cathinone. The first one, for example, contained MDMA, ketamine, 4-methoxymethamphetamine, ethylone, and caffeine. One of the ones that I find the most alarming is the one third from the bottom, that contain heroin, fentanyl, acetylfentanyl, ethylone, and then several adulterants. But heroin, fentanyl, acetylfentanyl, and ethylone really is quite a concerning combination of materials. And then something that we don't typically think about is the combination of cannabinoids and cathinones together. And so these were seizures of plant material that were analyzed and found to contain combinations of synthetic cannabinoids and cathinones. So for example, alpha PVP and AB Panaca were both found on a smoking blend. Phenethylamines, or phenethylamine hallucinogens, is the third class of synthetic drugs that I'm going to talk about. And these are ones that typically are abused the same way or are encountered the same way that LSD would be encountered. So it could be found as a powder, a tablet, liquid, blotter paper, sugar cubes, window panes, any way that LSD would be encountered. The phenethylamine hallucinogens are also typically encountered. And they basically fall into three classes. And the first one is what I call 2CX, where X can change. So these are our substances such as 2CI, 2CB, and 2CC. We also have what I call the DOX class, which is DOI, DOB, and DOC. And what that is, you see this pattern of I, B, and C, is the difference of one atom, right? So from an iodine, which is I, is changed and remove that and add a bromine, which is B, or a chlorine, which is C. Same for DOX. So it's a I, a B, or a C, which is an iodine, a bromine, or a chlorine. And we see the same sort of substitution for a class of drugs called Nabomi, which is 25I Nabomi, 25B Nabomi, 25C Nabomi. These three substances were all placed in Schedule 1 in November of 2013. So Nabomi, which is actually short for a long chemical name, also goes by the name of N-bomb or Smiles. Very typically, we hear it referred to as 25I or 25I, or 25C, 25B. And the structure of this material is listed below, or at the bottom. From January 2011 through August of 2015, there were over 4,800 drug reports where one of these Nabomi compounds were identified across 43 states. And between March of 2012 and August of 2013, some combination of the three of those were responsible for at least 19 deaths. Unfortunately, I don't have any. That information was used as in the emergency scheduling of those materials, or the scheduling of those materials, and overdoses continue throughout 2014 and 2015. So in terms of trends, the numbers of seizures and identifications with these materials is not as high as some of the other synthetic drugs that I mentioned. But what's important is not necessarily the number of seizures and identifications, but the potency of these materials. These synthetic hallucinogens, or phenethylamine hallucinogens, are potent to the level of LSD. And there have been numerous reports of overdoses and fatal overdoses. And just to put it in a little bit of context, Within this same time period between January and December of 2015, DEA reported 30 identifications of LSD. And so that's only 3 times more than 2,5-I or 25-I Nabomi. Okay, the final class of drugs that I'm going to discuss is synthetic opioids. And fentanyl has been getting a lot of attention, and in addition to heroin, and it's very difficult to separate the two. So what I'd like to do is give a little bit of history on fentanyl and fentanyl here in the United States, talk a little bit about heroin, and then why we need to understand the market of both to understand this phenomenon. So fentanyl is a potent synthetic opioid that's been used in medical practice since the 1960s. And fentanyl abuse is very long-standing. So pharmaceutical preparations such as lozenges and lollipops and patches are diverted or stolen for illicit abuse. The fentanyl epidemic that we are referring to here is not the pharmaceutical diversion. This is something different, and while that is a very serious problem, it's not really what I'm going to focus on this afternoon. Back in 2005 to 2007, there were over 1,000 confirmed non-pharmaceutical fentanyl-related deaths in the United States. And the fentanyl that was responsible for those overdoses originated from a single laboratory in Toluca, Mexico. And in 2007, that laboratory was discovered and shut down. The fentanyl at that time was about 20 to 25% pure at the wholesale level. So what that means is coming into not street level fentanyl, but fentanyl at the wholesale was 20 to 25%. So in our laboratory, some of the work that we do is to provide in-depth chemical analysis of heroin to determine the source area of origin and the purity of the heroin found in the United States. So we do a series of chemical tests and analytical tests to determine where the poppy was grown and how it was converted and extracted and converted into heroin. So we analyze seized heroin at the wholesale and retail levels, and the purpose is to provide a snapshot of the U.S. heroin market. So high purity fentanyl exhibits, an exhibit is what we call a drug seizure, have not been detected at the wholesale or retail level. So compared to the fentanyl that we were identifying in 2005, 2007, upwards of 20% fentanyl, we're now seeing it lower from 0 to 6% fentanyl. And we are also seeing fentanyl with and without heroin. So we're seeing fentanyl on its own, but also heroin laced with fentanyl. So when fentanyl is present with heroin, the heroin can be found from trace amount to very high purity heroin, upwards of around 85%. The heroin that is typically laced with fentanyl is of South American origin. Or South American-like heroin. So this is powdered heroin, not black tar heroin, that is common in the southern, southwestern part of the United States. The powdered heroin is also adulterated, and the adulterants that are identified in these heroin seizures are the same adulterants that we see in East Coast heroin markets, such as caffeine, quinine, acetaminophen, and diphenhydramine. We're also identifying dipyrone. Dipyrone is an interesting adulterant because it's one that is somewhat unique to fentanyl. So now there have been over 700 deaths in the United States related to fentanyl and its analogs between late 2013 and late 2014. This information comes from the 2015 National Drug Threat Assessment Summary, which was published in October. The fentanyl overdoses certainly continued within 2015. And what's interesting from this map is the widespread fentanyl overdose incidence across the eastern United States. There is somewhat of a void, not that it's not identified in the southern part around Texas and New Mexico, in that part of the United States, but most of the heroin in that region is of Mexican origin and is of a like a black tar, and it's more difficult to lace black tar heroin with fentanyl, since fentanyl is a powder. So we do some very low-level analysis of submitted fentanyl, or of fentanyl exhibits submitted to our laboratory. What we're finding is that the majority of fentanyl that we're identifying has less than 10%, so about half that of what we were seeing in 2005 to 2007. We are attempting to identify the synthetic route that was used to manufacture it. What's difficult with that is that there's so few impurities in the fentanyl that we're identifying that it's very difficult to determine how that fentanyl is being synthesized. What that means to us is that current fentanyl samples in the United States are indicating very skillful synthesis and skillful production from batch to batch. In addition to fentanyl, we're seeing many new fentanyls or fentanyl derivatives. For example, acetylfentanyl. Acetylfentanyl was first identified in the United States and Maine in 2013. It's not approved for medical use in the United States and was listed as a Schedule I substance in July 2015. There were more than 50 confirmed fatalities involving acetylfentanyl between 2013 and 2015. This information comes from DEA's Office of Diversion Control and is listed in the acetylfentanyl DEA fact sheet, which is accessible online. But it says, according to DEA's Star LIMS and National Forensic Laboratory Information System, federal, state, and local forensic laboratories reported 10 exhibits identified as acetylfentanyl in 2013 and 40 in 2014. So in 2015, we identified 62. So the number has increased quite a bit between 2014 and 2015. We've also identified 239 fentanyl exhibits in that year as well. There are some new materials listed here, such as butyrylfentanyl, W18, beta-hydroxythiophentanyl, and 4-ANPP. 4-ANPP is a precursor to the synthesis of fentanyl, and butyrylfentanyl and beta-hydroxythiophentanyl are fentanyl derivatives, or fentanyl analogs. The other interesting statistic that substantially increased in the last year is something called substance unconfirmed. And what this means in our laboratory system is that there were 83 instances where there was a drug present, but it couldn't be identified. There are many new substances here in the United States that we are working to still identify. Here are some additional ones. The butyrylfentanyl was first identified in the second quarter of 2015, and beta-hydroxythiophentanyl was identified in the third quarter of 2015. There are some ones here that have not yet been identified, but they are certainly on our radar, and ones that we suspect that we will be seeing here in the short future, such as valeryl fentanyl and furanyl fentanyl. There are some additional synthetic opioids, MT45, AH7921, U47700. These are other synthetic opioids that we have encountered, with the exception of U47700, but that's one that we view as an emerging threat. This is, for those of you that are not familiar with the National Drug Early Warning System, these are the sites that were selected as sentinel community sites here in the United States, where there's extensive studying and research being conducted in drug, in the area of drugs. Our laboratory system is set up, we have 8 forensic laboratories throughout the United States. And although I wasn't able to get as granular as those individual cities, what we were able to do was to look at those sentinel sites and the location of our laboratory to get an idea of what the 5 most common synthetic drugs were in those areas. So in the upper northeast, there are 3 sentinel sites, and we have 1 DEA laboratory. And the top 5 identified synthetic drugs were fentanyl, ethylone, AB Kemanaka, XLR11, and acetylfentanyl. From many reports that we've seen in the emerging heroin threat and fentanyl threat in the upper east United States, it's not surprising to see fentanyl as number 1. In the southeastern United States, there are 2 sentinel sites, and the top 2 are synthetic cathinones, which again, with the widespread abuse of flocka, it's not surprising to see ethylone and alpha PVP at the top of that list. What you will notice also is that fentanyl is listed in one of the top 5 for every region, with the exception of the blue section at the bottom, where there's 1 sentinel site. And those are the top 5 synthetic drugs seized and identified in that area are all synthetic cannabinoids. So in summary, I thought I'd just share some of my closing thoughts with you. That over the last 10 years, we've identified as an agency over 300 new drugs here in the United States. At its highest, we were identifying about 1 to 2 new drugs per week. And although that slowed for some time, we are seeing it increase in frequency here recently. And so I think that it's really important that we continue to be diligent in identifying these new threats. One of the things that has always been a challenge as a forensic laboratory is making an identification because of the lack of available reference materials. Although that's really improved here in the last couple of years, there's many more reference materials available for forensic laboratory use. Also, that's important to mention is that China, which is a source country for many synthetic drugs, banned 116 new psychoactive substances in 2015. And NPS stands for new psychoactive substance, which is a term that's used internationally when speaking about synthetic drugs. I think it's important that we continually evaluate new classes of drugs and new drugs within those classes so that we continue to understand this threat that we're facing. And again, it's important that we have early and frequent communication, not just as a forensic community or a toxicological community, but within each other or with each other, and that we continue to do that so that we can combat this problem together. And with that, I'd like to say thank you. Thank you for participating and joining the webinar today. I'd again like to thank Erin and Kathy and everyone here at NDEWS and CESAR for putting this together. I'd also like to thank my group at the laboratory, that is doing tremendous work and help to compile this information. Did we read the question? Okay. Okay. So the first question is, I am curious about the fentanyl addition to heroin. It must make economic sense to the illegal drug producers to add it, but heroin is so cheap to make, and it's so hard for me to understand why would they would add it, except for the boost it gives to heroin. Is fentanyl super cheap to make? Fentanyl is an extremely hazardous material to be working with, and the potency is quite high. And so that is one of the reasons to add fentanyl is to increase the potency, so that it's a heroin that would have a more of a pharmacological effect.
You can skip the next couple.
Oh, okay.
And the next one is, what is
okay.
black tar?
So the next question was, what does black tar heroin mean? So heroin can be manufactured many ways, and one of the ways that's predominantly used in Mexico makes a heroin that is not a powder. It's actually a black or brown, very sticky sort of substance, and it actually has the appearance of tar. The next question was, what was the threshold used to determine if a state had an issue with fentanyl in 2013-2014? I believe you're referring to the map from the 2015 threat assessment, or the National Drug Threat Assessment. And those were states not that had an issue with fentanyl, but those were states that had confirmed overdoses within 2013 and 2014, confirmed fatal overdoses. The next question is, if the lab my office uses does not test specifically for acetylfentanyl, will it pop it all on a drug panel that does test for fentanyl? I believe this question is referring to like drug testing of human not the actual drug, but like for drug testing. And I believe, I'm not 100% sure, since we test parent drug and we don't do any toxicology work, but I believe that acetylfentanyl may. I'm sorry that I'm not able to answer that question better, but I couldn't get back to you. If you want to get in touch with me, my contact information is on this slide. The next question said, where in the world do you think the fentanyl and analogs are being manufactured? There are a couple of source countries, the United States not being one of them, that are manufacturing all of the synthetics. There's been some strong support in seeing the relationship between China and fentanyl, as well as Mexico and fentanyl. The next question is, what is the relationship between the DEA and states and DC? Meaning, how often is information shared between the DEA and states, labs, law enforcement, drug prevention, and treatment agencies regarding emerging drug threats? There are a lot of offices within the Drug Enforcement Administration that regularly share information between states, other agencies, internationally. The states, particularly laboratories, I believe it's 90-95% of the forensic laboratories in the United States provide data to the National Forensic Laboratory Information System, or NIFLS. And so there's information that the state laboratories are providing to DEA that the DEA then compiles that information and summarizes it in reports, and you can always reach out for information as well. But that is not something that our laboratory does, but that is something that DEA's Office of Diversion Control is responsible for. There have also been numerous drug prevention and focus groups that have been formed recently, particularly regarding heroin. There's been a lot of information shared between DEA and states and other agencies in this area as well. Have you been seeing an increase in clandestine tablets? I would say not necessarily. I haven't seen an increase in clandestine tablets, but clandestine tablets are still something that is still very much prevalent here in the United States. In regards to synthetic drugs, we do see clandestine tablets with cathinones and synthetic or phenethylamine hallucinogens. Could you please tell us which drugs you see most commonly used in vaporizers or e-cigs? Vaporizers and e-cigs are most commonly used to smoke either vapor or nicotine. That's really the common use for them. We've seen vaporizers and e-cigarettes used to smoke synthetic cannabinoids, and also marijuana and butane honey oil or wax, which is a concentrated form of THC where it's extracted from marijuana. This one says, can you give us some information about kratom? Very briefly, I can. Kratom is a plant that is not controlled. The psychoactive component of kratom is mitragynine. So I have some additional information about that if you're interested. My contact information is included.
We'll also be posting Q&A on NDEWS.
Oh, okay. Also, NDEWS is going to be posting a Q&A regarding kratom, so please look out for that as well. Can you comment on designer benzos such as atizolam or clonazepam? Are these compounds being found by the DEA labs? Yes, that's, in 1 hour, I did try to keep this relatively focused, but designer benzodiazepines are certainly something that we are identifying, and it's certainly another trend in synthetic drugs in the United States, and we have seen atizolam and clonazepam as well. Will the slides be available?
Yes.
Within a week, the slides will be available. The next question is, can fentanyl be differentiated from acetylfentanyl or other derivatives in laboratory testing conducted in settings such as hospital emergency departments? Again, this is very similar to the question prior to this. From a forensic chemist perspective, fentanyl and acetylfentanyl are readily distinguishable in laboratory testing. Regarding hospitals and whether or not fentanyl and acetylfentanyl can be differentiated, I would have to look at that, and maybe that's something, since there does seem to be some interest in that, something that maybe we could provide through NDEWS. Reference has been made to monitoring markets, and it sounds like the sampling strategy is based on law enforcement seizures. However, many of these drugs appeared in online markets before the first reported seizure. This raises the question of whether or how internet-based markets are being used to identify emergent drugs. Absolutely. So really the way in which we identified that this was a problem was before it even made its way here into the United States. It's something that we watched happening in Europe and sort of saw right before it came what was coming. And there is this, the internet and the availability to purchase these materials online is certainly contributing to this market. That's something, it's readily available. It's very easy to buy. You can purchase it with a credit card online. There are many websites where these materials are able to be purchased. So it's that's really what the market is much bigger than what we've actually seized and identified. There are still many more substances that we know are or suspect based on names and product lists that you can go online and look at yourself that are out there, but we are only reporting on what we've actually found and identified. The next question is, given that China is such a significant source for these chemicals, is there any discussion about coordination with their regulatory authorities to share findings to get these NPSs banned? The answer to that question is yes. There are ongoing conversations. They are interested from levels way up on high about working with them on an international level to identify threats or these substances in countries around the world as well as here in the United States, and to bring that to China's attention. And really, they controlled or banned such a large amount of drugs in such a short amount of time. So those sorts of conversations are leading to more regulatory efforts on their part. Is the Pacific Northwest, you've identified substance unknown as #2 trend? Is this multiple substances? Any thoughts on why this region is seeing more introduced NPS? There could be a lot of factors as to why substance unknown is that high. It could be that there are new drugs going into that area. It could also be the availability of reference materials at that time. In order for a forensic laboratory to make an identification, there must be a standard or a reference material for comparison. So as I mentioned before, those substances unknown or unconfirmed may change once a standard is available. You listed 5 other synthetic opioids in addition to fentanyl synthetics. Do you know what the properties of these are? Are they similar to heroin, fentanyl, oxycodone, and something else? I can talk very sort of anecdotally about that. That's not really my area of expertise. But many of the synthetic opioids are more potent than morphine. So I think I have actually. So for example, the acetylfentanyl, and this is somewhat anecdotal information, but kind of a good starting point, is the acetylfentanyl is 10 times less potent than fentanyl. The butyryl fentanyl is about 1/4 the potency of fentanyl. The one that is the most alarming to me is W18. W18 is one that was originally synthesized for research, but was found to be 10,000 times more potent than morphine in the original literature. I don't know if there's been additional work done with that material, but that's one that that's concerning to me. Do you share information with European tracking organizations like EMC, DDA? If so, to what extent? Do you see drug trends begin in Europe and transfer to the United States? Prior to the emergence of synthetic cannabinoids in the United States, typically drug trends would begin in Europe, and then we would see them here about 6 months, 8 months later. We would typically follow the trend. What we're seeing now is sometimes there's a new one in Europe and sometimes there's a new one here in the United States. But both Europe and the United States are seeing a lot of synthetic drugs and across several classes. We do share information with the MCDDA. We communicate with them, and I think it's important that there is a lot of communication between agencies across between Europe, Australia, United States. It's important that we be sharing information. The next question is, knowing so many fentanyl analogs exist, how many forensic and toxicology labs choose which tests to use? Are there any recommendations, standards, or turnaround times affected? So that's a question that really is sort of the crux of what the challenge is to many laboratories, is how to determine where to spend the money on which standards in forensic chemistry and in toxicology labs. That's a challenge, and that's one of the areas where I hope that this information that I provided today is useful to show where the trends are and what the most widely seized by our agency and what we're seeing across the United States. So maybe some of those efforts can be focused on those particular substances. Granted, this is not all encompassing of every drug seizure we made in 2015, but it may be a good snapshot. And turnaround times are certainly affected quite significantly while laboratories wait to purchase and verify reference materials. I'm going to be able to take a couple more questions as we're wrapping up. So I'll go through a few more. Knowing so many, I just did that one. Okay. As for an efficient and more credible drug prevention, it would make sense to add a little bit of pharmacology besides a listing of structures. I absolutely agree. There's a lot of as a forensic chemist, this isn't something that, this isn't my area of expertise. But maybe that's something that's a great idea to provide as feedback back to NDEWS, that would be something that you would be interested in hearing, maybe from a pharmacologist that would have the information to be able to provide a presentation on that. Many of these I think I spoke about. Okay, so I think at this time we're going to wrap up the questions. Again, thank you for tuning in today and this afternoon, and I really appreciate again the opportunity to speak with you and provide information. Thank you.
Hi everyone, hopefully you're all still with us, and thank you so much for coming to our webinar this afternoon and listening to Jill's presentation. And as we have mentioned, a recording of this webinar will be posted on the NDEWS website at www.ndews.org. And if we didn't get to your question, I apologize for that, and you can certainly send it to us at the NDEWS email, ndews@umd.edu. NDEWS@umd.edu, and we'll be happy to get back to you on that. And I hope that you will be interested in joining us again at our future webinars. Our next presenter will be Dr. Wilson Compton, who's the Deputy Director at the National Institute on Drug Abuse, and he will be presenting on heroin, which I know is a topic that has affected many, many parts of the country in the past couple of years. So that will be an important discussion for us to have as well. And I know a number of you were asking about fentanyl and the fentanyl analogs, so I would encourage you to go to the NDEWS website and check out our special report on fentanyl, and hopefully you will find some information to address your questions there, either in our report or in some of the DEA reports that we link to from there. So thank you again for joining us, and I think we're going to ask a couple quick questions to get your impressions about the webinar. So if you don't mind participating in that before you sign off, we'd appreciate it. Thank you. All right. Thank you again, everyone. We really enjoyed having you and look forward to meeting with all of you again in March.